Okay, we are on Unit 4, Activity 3, and this is where things start to get really important. What we're looking at here are series circuits. So, what I've done is I've set up a simple circuit. It's got a one-cell battery with a voltage total of 1.5 volts. At load number 1, our voltage is 1 volt, and at load number 2, we know that our current is 2 amps. Now, rule number 1 in a series circuit is your current is the same everywhere. So if you have a current of 4 amps, that will be your current at number 1, and that will be your current at number 2. So if we have 2 amps here, we have 2 amps here, and we have 2 amps here. Now, in this video, I'm not explaining why this happens. They've got a couple of activities to do in your content. What I'm doing right now is I'm showing you what's important to know in this unit. Here we go. Let's take a look at voltage within here. So voltage total equals voltage 1 plus voltage 2. So where IT is equal everywhere, we have a total voltage drop across the system. In other words, if our voltage total is 1.5 volts, our whole system must add up to 1.5 volts. So voltage total equals V1 plus V2. Voltage total is 1.5. If voltage 1 is 1 volt, what's voltage 2? Voltage 2 is going to be 1.5 minus that 1 volt equals 0.5 volts. So all of the voltage that's gained within the cell or battery is lost throughout the system. Now, how do we find resistance in here? Resistance total equals resistance 1 plus resistance 2. We now know our amperage and our voltage in each situation. So to get our resistance, we take our voltage and we divide it by our amperage, and that's equal to 0.5 ohms at number 1. At number 2, we have 0.5 divided by 2, which is equal to 0.25. So our total resistance is going to be that 0.5 ohms plus the 0.25 ohms. Our resistance total is equals to 0.75 ohms. Now, they don't really address this too well. I've sort of addressed it already. But if we have 3 1.5 volt batteries, here's how you draw it. There's your positive and negative terminal of 1, positive and negative terminal of 2, positive and negative terminal of 3. That's 3 times 1.5 volts equals 4.5 volts for that battery. Okay, just be aware when you line batteries up in series, they become more powerful. Now the problem with this is they lose time, so those batteries don't work for a long period of time. Let's take a look at the setup that we have here. We have a setup where we've got a voltage total of 4 volts. Here we've used 1 volt. So within a system, we have to have a full droppage of voltage. So if we start with 4, we lose 1, we've got 3 volts left in the system. What's our amperage? 2 amps there, because no matter what, within the system, whatever amperage you have here is the same amperage you have here is the same amperage you have here. If we want to get our resistance, we go volts over amps, volts over amps. So that would be 1/2, and that would be 1.5, and we would have 2 volts or 2 ohms of resistance total within the system. So we've answered the question, what's our current running through 1 and 2? Potential drop across the second resistor we addressed. resistance of the two resistors we've addressed, and we got our total. Potential gain by each cell in the system. Well, we know our voltage is 4 total for the whole system. We figured that out, or we were given this. So we've got 2 cells. So if we have 2 cells, that's 2 volts each to get that 4 volts all together. Folks, try and get these rules for series down. Write them out on a piece of paper so that they make sense to you.